notes, just pick up where you left off yesterday. So you can add it to your 4.2 notes from yesterday. Add it to those, but maybe make a little note to yourself that this is actually section 3.5 from your book. And what we're going to do is we're going to talk about limits. Don't let that scare you because, like I said, it's really not that bad. We haven't really talked about what happens when you have a function and the limit. What happens to the limit of a function as the x value, instead of just approaching a number, let's say it approaches infinity. So if you have some limit as x approaches infinity of some function, or if you have some limit of a function as it approaches, I forgot my little negative, it's supposed to be a negative infinity here, of some function, what happens? What do? The first thing that you need to do is just try substitution. Try substitution to begin with, and then I'll show you what are your possibilities for outcomes here in just a minute. Try substitution first. So let's say, for example, that I ask you to find the limit as x approaches infinity of 6x. What is the value of this function as the x value approaches infinity? Well, just think about that. If the x value is getting bigger and bigger and bigger and bigger and bigger, what's happening to the value of 6 times a really, really big number? It's getting really, really big. Wouldn't you agree? All right, so what is 6 times infinity? Infinity. What about this? Let's say you have the limit as x approaches negative infinity of negative 2x. What happens there? Negative 2 times a very, very large negative number. What do you get? What is a negative 2 times a negative number? It's going to be positive. Now, that doesn't mean you couldn't ever get a negative infinity, but in this case, it just so happens that you are going to have a positive infinity. All right, but other things can happen too, of course. Like, for example, what if you have the limit as x approaches infinity of 2 divided by x? What do you get? So let's think about this. The x is on the bottom, and the x value is approaching a very, very large number.
0.
Very good. So you have 2 divided by 10. What do you get when you have 2 divided by 10? 0.2. Let me ask that again. What is 2 divided by 10?
0.02.
0.2. Okay, very good. As I increase the value of the denominator, for example, 2 divided by 100, it becomes 0.02. What if it's 1,000? 0.002, etc. See, so I keep making the denominator bigger, and the value of the function keeps getting closer and closer and closer to 0. Will it ever be 0? It won't ever actually get to 0. In theory, it will never get to 0. So as the limit approaches a very large number, this is getting close to 0. So you're not always going to get infinity as an answer. You won't always get negative infinity of an answer. Let's make a little note here. Whenever you divide by infinity, it will approach 0. That always happens. So let's just quickly do this one. What about the limit as x approaches a negative infinity of 4 divided by x? So we're putting negative numbers down here. What is it getting close to? 0. It's getting close to 0. It's going to be a negative number, but it's going to keep getting closer and closer and closer to a value of 0. Yes?
What if there's like an equation for the numerator? Would it still be 0?
Yeah, we're going to talk about those. We're getting there. Okay? What about this? I'm going to call this an example. What about the limit as x approaches infinity of 5 minus 2 over x squared? Okay, well this 5 doesn't have a variable with it, so regardless, it's always going to be 5. So here we're just going to have 5 minus, well, if I put an infinity in for the x squared in the denominator, what is that approaching? 0. I'm taking infinity squared. Infinity squared is even bigger than infinity. So that means you're taking 2 by an unbelievably large number. What's it approaching?
0.
It's approaching 0. So you have 5 minus 0. What is 5 minus 0? 5. So in that case, the limit would be 5. All right, what about, can I flip? What about this? You have the limit as x approaches infinity of, this is getting to your question, Joey, 2x minus 1 divided by x plus 1. What's happening there? Well, let's plug in an infinity in for x in the numerator. If I put an infinity in for x, we have 2 times infinity. What kind of a number is that? A very large number. But we have to subtract 1 from it.
So it's negative.
Infinity, a huge number. Minus 1.
It's infinity.
It's still infinity, right? Subtracting 1 from it. You're subtracting a very small amount from it. So the top, you still have infinity. Would you agree? All right, now what about the bottom? If you put infinity in for x in the bottom, what's infinity plus 1?
Even bigger.
Even bigger. It's infinity. So we have a situation where we have infinity divided by infinity. Do you remember when we were doing limits and we would get 0 over 0? That meant that we had to explore more. That's what it means here, is we have to, in the exploring, let's try this again. The exploring in this case, you guys, is not nearly as bad as it was before, I promise you that, okay? So if you get infinity over infinity, that means that you have to look elsewhere. So what I want you to do right now is go to y equals on your calculator. Those of you that have your eyes closed and picking split ends off the end of your hair and all that kind of stuff, you need to knock it off. It is only day
1.
2, 3, 5 of the semester.
Senioritis.
Okay, oh geez, we got a long way to go, you guys. Go to y equals, please. And I want you to type in 2x minus 1 divided by x plus 1. Make sure you separate the numerator from the denominator with parentheses. Make a table. And I want you guys to, when you type it in, set up your table to start at a big number. Start at 1,000. Start at 1,000 and count by 1,000s. What's happening?
It's
Getting closer to
It's getting closer to what?
2.
It's getting closer to 2, isn't it? Getting closer and closer and closer to 2.
Yeah, count.
Did I do it?
Yeah.
All right, so we know that the answer should be 2. Now, by the way, that what I just showed you, to put that into your calculator and try to get an answer, you're not allowed to do that. I was showing you that that's how it works, but I'm going to expect to see the calculus behind it, of course. We know when we put this into our calculator that it should be approaching 2. We know that's our answer. Now we need to get there. So let me show you what you need to do to get there. So you take your limit. X approaches infinity of 2x minus 1 over x plus 1. When this happens, when you get an infinity divided by an infinity, this is what you are going to need to do. You are going to divide every term by the smallest degree term in the denominator. And that might sound horrible, but it's not. So just hang tight for a minute. No. Yeah. So you look at the denominator. What is the smallest degree term in the denominator? And you know what? I didn't write that there, maybe we should add that in there. So when you divide by the smallest term, the smallest degree term in the denominator, that does not include the constant. Now the constant here is a 1, which really has a value of 1x to the 0 power. You don't divide by that. You find the lowest x, the lowest power of x in the denominator, okay? In this case, an x. I think I have that wrong.
Oh my gosh.
Hold on, no, just don't freak out on me yet, okay? I can't believe that I did that. This right here is supposed to be largest.
That's what
I don't know why. I'm sorry. I apologize. The largest degree term in the denominator.
Either way, it's still gonna be x.
Yeah, so it's going to be x. So this is what you have to do. You need to, I'm just going to look at the function, 2x minus 1. Leave yourself some space. You have x plus 1 in the denominator. You have to divide by everything, all of the terms, by x. So you're going to divide this by x. You're going to divide this by x. You're going to go up to the numerator and you're going to divide everything by x also. And then you just simplify everything. So like this 2x divided by x, they cancel out. What does that give you? 2 minus 1 over x. You can't simplify 1 over x, so you leave it 1 over x. Divided by, what is x over x? They cancel to give you 1 plus 1 over x. And now what you need to do is calculate the limit as x approaches infinity of your new function. So I need some help transferring this onto my next screen if you guys don't mind. Can I split pages? You have everything down? Yeah.
Why can't you just cancel out the 1 over x and then do 2 divided by 1 equals 2?
Well, that is what you're doing. But sometimes they're not that easy to recognize.
Gotcha.
Why is 1 over x just 0? What do you mean? Just get rid of it. Why can you do that? You can, but why can you?
It's dividing by.
Yeah, you're dividing by infinity. If you put an infinity in here for x, what is 1 divided by infinity?
0.
We just talked about that a couple pages ago. It's going to be 0. So really on the top here you have 2 minus 0, and on the bottom you have 1 plus 0, because 1 over x here is also going to be 0. So what is the limit as x approaches infinity? You guys, what's in the numerator again? It was 2
1 over x.
plus
Minus.
and on the bottom you have 1 plus 1 over x. Okay. So if I put an infinity in for this x right here, I'm going to end up with 2 minus 0. Are you okay with that? 1 divided by infinity is 0, so we have 2 minus 0 in the numerator. The denominator is going to be 1 plus, what is 1 divided by infinity? 0. What is 2 minus 0? 2. What is 1 plus 0?
1.
What is 2 divided by 1?
2.
We already knew the answer was 2, right? Right?
Yeah.
Yes. All right, another example. Let's do the limit. And some of you might only need to hear me do one more example, and then you can probably try this on your own. The limit as x approaches infinity of 2x plus 5 over 3x squared minus 1. Well, if I put an infinity in for x on the top, I have 2 times infinity plus 5. That's infinity. And then on the bottom, I have 3 times infinity squared minus 1, which is also infinity. And then whenever you have infinity over infinity is when you need to explore that thing I just told you about. So you look at the denominator. The denominator is 3x squared minus 1. So what are you going to divide by? just x squared, not the smallest as I had it written. Oh, I'm sorry I did that. You are going to divide everything by x squared. Divide by x squared. Divide by x squared. The denominator, you have 3x squared divided by x squared minus 1 over x squared. And then you just have to simplify.
Why don't you use the 3? No comment.
Because you have 3 of the highest exponents. The highest.
That's just a rule. I don't know. I don't have an answer for that. These cancel out. Agreed? 2x over x squared. What's that going to get you? 2 over x. 5 over x squared does not simplify. This leaves you with a 3. What about this? Stays the same. Does not change at all. What? Okay, now we have to do the limit. The limit as x approaches infinity of 2 over x plus 5 over x squared divided by 3 minus 1 over x squared. All right, what about 2 over x? What happens if you replace x with infinity?
0.
You get 0. All right, what about this? 5 over 0, or infinity squared is 0. What's it looking like right now?
0.
Yeah, you're going to have 0 on the top. What about the bottom?
3
Yep. 3 minus 0. You get 0. So in that case, the limit is going to be 0. It's not bad, is it?
Would we ever get one where it's infinity divided by infinity and then we do all that stuff and 0 divided by 0?
Yes, you could still get it. Yeah, you could. You could still. You would end up with a. The limit then in that case would be. Wait. Could you get a 0 over a 0? Oh gosh. Could you ever? You will. I will say that you could get a situation where you could have a does not exist. But will you ever get a 0? I don't know. That's a good question. I have not come across one yet. Okay. All right. If you want to get started. The assignment's on the board. If you want to see one more example, then I'm going to do one more example. But all I'm asking is that you are not talking when I'm going through my one last example. The limit as x approaches infinity of 2x squared plus 5 over 3x squared minus 1. You plug in infinity for those x's, you're going to have 2 times infinity squared plus 5. That's a really big number. That's going to get you infinity. Same thing's going to happen on the bottom, so you're going to have infinity over infinity. So now what you need to do is explore this option. So I'm going to divide everything by the largest degree on the bottom, which is an x squared. So I have 2x squared divided by x squared plus 5 over x squared divided by, on the bottom, I have 3x squared divided by x squared minus 1 over x squared. And then I just have to simplify where I can. The x squareds are going to cancel out. These x squareds will cancel out. And that is going to leave you with 2 plus 5 over x squared divided by 3 minus 1 over x squared.
Can you wait a second?
Yep.
Third.
So now what we need to do is find the limit as x approaches infinity of 2 plus 5 over x squared divided by 3 minus 1 over x squared. So on the top, we're going to have a 2. 2 plus what, for those of you listening?
2 plus 0
2 plus 0. 5 over x squared is 0.
over 3 minus 0.
And then you're going to have 3 minus 0 on the bottom,
2/3.
which leaves you with 2 over 3.
If we know how to do all that, it's not actually doing any sense. Can we just get to the next over?
Yes.
Okay. 'Cause
Now, you guys, Marissa just asked a good question. If we know how to do all that stuff in our head, can we just get to the answer? If you do this, if you go from this problem and you give me the answers 2/3 right off the bat, I'm going to be a little bit suspicious because I just showed you how you can just type it into your calculator and you can figure out that it's approaching 0.6666. You know what I mean? So I am going to expect to at least see that you're dividing everything by it. I would expect to see that. Is that fair?
At least expect to see what?
I would at least expect that you're showing me that you've divided everything by x squared. I get that if you can, that you could look at this and go right to here. I understand that I'm getting to the point where I can go right from here to here too. But going right from here and going right to here, I just don't know if you did the math, if you just looked at your calculator or if you actually did what I asked you to do. Okay? Yes?
When you always divide it by something, is it always infinity over infinity?
Is it always going to be like that? No, sometimes it won't be like that. Sometimes, it just depends on the function. Sometimes you won't end up with infinity over infinity. Today, will it be infinity over infinity? In your problems, I believe so, but it will always be that. Okay?